Okay, long chain alkanes are converted on an industrial scale into alkyl sulfates for use as detergents. Okay, if you look at this molecule, okay, they say which statements can be deduced from the structure given. But when you look at this molecule, you notice this part is actually ions. So ions actually are soluble in water. Okay, they're actually soluble in water. Okay, soluble in water. So water actually, it means this is a polar solvent. Can all right. So why is it soluble in water? Because it can form what they call ion dipole. Okay, it can form ion dipole interaction in water, which means something like this. O is an ion here. It can form ion dipole with water. Even Na+ can form ion dipole with water. Okay, this is the ion dipole. All right, ion dipole. Delta plus here. Okay, this part here of the molecule, this part of the molecule, right, it's actually non-polar. All right, non-polar. It's just a hydrocarbon, so it's actually going to be it'll be soluble in the non-polar solvent. That's why we teach you this concept of like dissolves like. Non-polar dissolves in non-polar, polar dissolves in polar. All right, so the compound can dissolve in both polar and non-polar solvents. That is definitely true. The shape of the sulfur is square planar. Sulfur actually has, okay, look at sulfur. Sulfur actually has 4 bond pairs. So the shape for sulfur is actually not square planar. In fact, it should be not square planar. 4 bond pairs, right? So it should be tetrahedral. All right. All the carbon-carbon-carbon bond angles are 109.5. So if you look at this whole portion, right, it looks like that. CH3. All right. And then after that, it's connected to CH2, but there'll be 10 of them. There are 10 of them. 1, 2. Okay, so you just continue, right? Yeah. So you notice all the carbons have 4 bond pairs around it. So it's again tetrahedral. So since it's tetrahedral, it'll be 109.5. Okay. So 3 is also correct. So the answer is 1 and 3. All right. This is going to be C.